The electricity that powers our digital future is very, very analog. Is that about to change? Welcome to Tech First with John Koetsier. We don't think a lot about the technology that drives our computers, our digital devices, our homes. We kind of flip a switch and we get to work, or we turn on the TV and watch something. But the actual mechanics of what's happening in our walls and in our wires is kind of very 18th century in a sense. One company is working on making that better. To dive in and explain more, we're joined by Thar Casey, who's the founder and CEO of Amber. Welcome, Thar.
Thank you, John. Thank you for having me, and appreciate to get the opportunity to introduce myself and Amber.
Excellent. Wonderful. Well, we're happy to have you. Let's start here. Most people are kind of vaguely familiar with electricity. You know, they throw a switch on the breaker panel occasionally. Maybe they get it, out there a little bit and change a power outlet. How does electricity work today in most homes and buildings?
Well, we don't think about it. It's a second nature. It's there when the house is built. The power and the light switches and the outlets, and it's all there. The circuit breakers. We don't think about it. When do we recognize there's an issue or there's a problem? When, for example, the GFCI pops, and we say, "Well, wait a minute. Why did this pop? What happened?" And now you start checking and see what's going on. And then you go to the circuit breaker and you see that the circuit breaker is not popped. It's still good. And then you go, wait a minute, I don't understand what's going on. Well, there's a circuit breaker and there's a GFCI outlet there that it tripped, and there's several daisy chain other outlets behind it that you're plugged in, and you don't know that there is that daisy chain. So in reality, we don't know. Okay.
Yeah.
And this is an issue, believe it or not, for builders. Brand new construction builders, they receive phone calls from the homeowners, typically within 3 months in the beginning, and sometimes even several years later, where they will have to send an electrician because the house is still under warranty. They send the electrician only to go over there and push a button on the GFCI and or to eventually replace it. So it's ironic. If it, to your question, a lot of people really don't know much about what goes on in their home from the electricity part of it. And
Exactly.
one more thing is very, very important. You go to a gas pump and you take a gasoline pump and then you put it in your car, and then you're looking at the meter and you're seeing what's going on. Electricity, it's going on all the time, and you have no meter to look at. You have no perspective. All you know in this case, you get the bill at the end of the month, you write a check, and you send it, and that's it.
Exactly. So what's your innovation? How are you changing this?
Well, it's very simple. Electricity right now, let's go back a little bit. The end point of the electrification infrastructure of every building out there right now, it's based on old technology. It's electromechanical. Basically, it's invented in some early century, last century, and some came in a little bit later on in the 50s and 60s, where the circuit breaker actual toggle circuit breakers that you're probably familiar with, like this,
Yeah.
it's a toggle switch. It's electromechanical, and
So when you say electromechanical, what that means is essentially you move a physical component, and a
correct.
physical component inside there connects, and then you
That's
have
correct.
a circuit connected when the metal touches metal, correct?
That is correct, 100%. So you got, in this case, something that you open and close, in this case, mechanically, physically. Okay. So the industry has perfected this. Okay. It's been around for a long time, since the 50s. Prior to that, there was a fuse. So we are taking it to the next level. We are going to bring solid state solution. So if you allow me, let me explain what a solid state
Please.
is. Solid state is like if you take your table, okay, which is a solid piece of wood. If you can mimic what an electromechanical switching opening and closing inside that table without any actual moving parts, that means you are now a solid state AC switching, for example. So that means there are no moving parts, but you're giving exactly the same as you are going to give inside a mechanical circuit breaker or switching. That's what makes solid state so popular, so great. That's what Silicon Valley is all about. And back in the 80s, what Silicon Valley, because solid state, it means it can be silicon. It can be a chip. It can be smaller. It can be intelligent. You can add firmware. You can add software. There are so many things that you can add to it. Now you have a mini computer pretty much when you have a chip.
Very, very interesting. So this is a major change, obviously, and it changes probably literally trillions of devices and connection points around the planet. That's a pretty big innovation. We're going to dive a little bit more into what that is and how it works and whether it's as reliable and what it actually unlocks. But what's your background? Why did you come to this innovation? What sort of highlighted this as something that you needed to fix?
Yeah, sure. No, thanks. John, I'm a serial entrepreneur. I've been in the world of Silicon Valley and innovation, if you will, back in the 90s. My first startup was a medical device company. Came up with my partner as a hearing device. It goes deep in the ear canal. You put it inside the ear canal. You leave it there for up to 6 months, 4 months. You sleep with it, shower with it, swim with it, and at the end of the day, it's disposable and it's totally invisible. You can never see it.
Wow.
And it's non-invasive, no surgery. The product's still in the market right now successfully, and it's still the only product in the world that is long-lasting and also disposable and invisible. And of course, back then, everybody laughed at us. They said, there's no way you can come up with anything like this. And we did, and we prevailed, and we pulled it off. Subsequently, we started a fetal heart rate monitor. We extract the fetus EKG from the mother's skin. The only way you can extract the fetus EKG is actually during the labor and delivery. You break the amniotic sac and you attach electrodes to the fetal scalp, and that's the only way you could get the fetus EKG. Anything prior to that, you using a Doppler ultrasound to extract the actual fetal heart rate. It is not the EKG with the QRS interval. We came up with a patch. You put it on the mother's abdomen from the second trimester, and you'll be able to extract the fetus EKG from the mother's skin. And that's totally incredible because there are a lot of risk pregnancies that a lot of people, they need to pay attention to, and that's an area that was needed. Then subsequently, I came up with a fingerprint sensor company for smartphones. Way before smartphones adopted fingerprint sensors, people laughed at me. They thought it was stupid. Nobody will put a fingerprint sensor on their smartphone because it costs $2 or $3. Well, end up costing, believe it or not, a little bit more than $2 to $3. And the cell phone market adopted the fingerprint sensor for securities and other means. My technology now, it's in we got acquired, and my company, my technology now is in different phones and also with in credit cards, and is being deployed in different parts of the world. So what I like to do is I like to come up with something disruptive. The common denominator between all of them, they're all silicon based, they're all semiconductor technologies. Okay, they all have to have hardware and firmware in this case. They're all mini computers to a certain degree. And Amber, it's the same, but it's in the power. So my co-founder and myself, he is a power expert. He's an electrical engineer, PhD in power. And his innovations is out there in so many different products right now. He's also an entrepreneur. So the combination between him being in the silicon and being an entrepreneur and power, and myself being a silicon and entrepreneur and also a semiconductor silicon guy, then combination, we end up coming up with Amber. Very disruptive technology.
So let's talk about making it solid state. Why is that better, and what does it unlock?
So I'll give you an example in here, and I came prepared. So this is what you're about to see right now is a conventional brick. This is a converter from AC to DC. Anything and everything out there that you need DC, okay, and it's connected to electricity, you have to have this, which is a brick. It has electrolytics, magnetics, transformers, rectifiers, components, if you will, that every electrical engineer out there in the world knows, and that's standard. Then,
so is that one of the reasons why when you get some little appliance and you plug it into the wall and it's got some big brick attached to it or something like that?
That is correct. That is correct. That is the brick. So it actually does have a name. It's called the brick, believe it or not. So
okay.
you're right on. Yes, it's called the brick. And so the nickname for this is the brick. And some of these appliances, like let's say it's your coffee machine, You don't see it in this case because it's inside the machine itself, but where you touch on the controller, it has this, because with the touch controller, it needs DC, cannot run on AC. Okay, so, and smoke detectors, carbon monoxide sensors, thermostats, all of those things, they require these things and more. I mean, I could go on almost every product out there. So we found a way to eliminate it and replace it with this.
Interesting. Hold those up side by side. That is just a little bit smaller.
Yeah, it's a little bit smaller. And so when you take something like this, and now you have no electrolytics, no magnetics, no organic materials that will dry up, a lot of times these things will fail before the actual product itself fails. This would fails first. So
Interesting.
you got a lot of advantages in here through a solid state. But
So
here's the
it's not
beauty. Yeah,
so it's not just the fact that it's smaller, which is nice, by the way, because who likes the brick? Nobody likes the brick, right?
sure.
But you're saying it lasts longer. It's not a point of failure.
The 100%. In addition to this, the beauty about this, because I can add software to it, it has a dynamic range on the input. It can be all the way from 45 volt up to 600 volt on the incoming. So for manufacturers, for a single SKU manufacturing worldwide, this is a very, very big deal.
Interesting. So you can have the same component across many different electronics
That is correct.
and get huge economies of scale.
That is correct. And cross all over the world too. So the same component that will work in the US, it can work in Europe. And so for manufacturers in this case, coming up with, let's say, smoke detector, they can have this. Okay, it doesn't matter on the voltage input. It could be, like I said, 45 volt, 100 volt, 110, 220. It doesn't matter. It will adjust accordingly, and then it turns it on. Where these are limited to only, let's say, 110 or 220, and they design them accordingly.
So in the future, I may not need to have 10 different plugins for going to Europe because I always forget it and have to buy a new one.
So to a certain degree, for the consumer right now, they try to cater to this by putting a little bit more sophisticated, a little bulkier bricks, or maybe there's a switch in there that you will do it. But think about, let's say, a large manufacturing company who is making, in this case, products for Europe, for Japan, for US, and now they have to make them different SKUs relative to the electrical power for these different parts of the world. And for if it's a US, if it's our technology, no, it's a single component. That's all they need. Therefore, they can have a single product, can be sold any part of the world.
Interesting. Let's talk about power surges. I looked at some of your documentation. You mentioned non-sacrificial surge protection. Talk about some of the durability factors and some of the safety factors.
Very good question. This is something called MOV. It's a fuse at the end of the day. Okay, but think about it, it's almost like a punching bag. This particular fuse, it keeps taking punches and punches every time there's a surge. Eventually will fail, and eventually when it fails, now the surge will go through to the home and eventually to the appliances or whatever it's plugged in. We found a way to eliminate this. We don't need it. And we will catch, in this case, the surge coming in, and we will eliminate it through our own proprietary technology altogether. And we will not allow the surge to destroy our own technology and our own AC switching or power conversion. And with that, we are not like a punching bag that will end up failing. No, because we eliminate surge. We do not allow it. We don't absorb it. We cut it and we eliminate it.
Very, very interesting. So in essence, by having solid state switching, you can cut that circuit almost instantly,
Well,
and
we
therefore not keep taking those hits.
absolutely 100%. Think about it. For circuit breaker, let's say the regular circuit breaker that we just talked about. Okay, this circuit breaker, it trips in this case when it trips, and you think it tripped very, very fast because that's what you know. You don't know any better. What if I tell you that our circuit breaker in this case, this particular one right over here, it does not have a toggle switch. It does not. It is solid state, meets UL requirement, and this circuit breaker is programmable. It has intelligence. It has Wi-Fi. It has Bluetooth. It has energy monitoring metering. It has surge protection, it has GFCI, and here's the best part. We trip 3,000 times faster than a mechanical circuit breaker.
Wow.
3,000 times. So in this case, you don't even get to see an arc because they're tripped. Okay,
Wow.
you don't get to see a spark when if you touch two wires because it's tripped. It's too fast.
I look forward to the day when I am not heading out to the garage to flick switches back and forth till I find the right one and
Well,
reset it.
that's a very good one. And actually, the electrician's going to be looking forward to this, or the maintenance in commercial buildings and industrial buildings when they go in to receive the notification instantly and they recognize why tripped, what
Yes,
caused the trip. Okay,
yes,
and in this case, they do the analysis before they even reset it. So that's
sure.
the beauty because
And
there's a computer in
they
there.
can do that remotely because it's remotely addressable, correct?
It can be absolutely. If UL in this case allows this, we will that it we have it. We demonstrated it. We revealed this at CES, and we demonstrate that we actually can remotely control a circuit breaker.
Very, very interesting. Okay, let's talk about smart home, IoT, smart buildings, those sorts of things. What are the implications of this technology for IoT and smart homes?
So, look, everybody's going towards smart homes. I love it because at the end of the day, you need, in this case, a home to be smart, not necessarily only to give you a better quality of life, but also to look after the house itself and starts giving you information if the house having a problem. We, through our technology, we're looking at both sides of the wall. On the inside, between the two walls, putting sensors in this case that will tell you what's going on in there. If there's any mildew, moisture, any of this stuff, this is a very big deal for brand new homes for builders. So this way it will save them money on insurance policies that they have to buy if there is any water leaks that they don't know about across their design. And of course, on the living side, quality, air quality, carbon monoxide, carbon dioxide. So to give you an example, you take something like this. This is a conventional smart outlet. It's an outlet and it's conventional outlet. We took it apart so you can see what an outlet looks like on the inside. This particular outlet has two functions only, two. Okay,
Yep.
it's wireless control and it has energy monitoring metering. Our I challenged my team to give me something equivalent to this or better. So other than the plastic and the metal, because you have to have it, everything else in here, it's really the technology.
Right.
This is our equivalent for it.
Wow.
Okay. I have that much more room to add sensors in this case. This is already tight inside the box that goes in the wall behind the light
Much so.
switch. This one is not the case. So what we revealed at CES with our technology, we put as many as 15 functions in one single gang box in a wall where the competition cannot. They
Yes.
can't. But let me tell you the difference between these two. This has dimming, this does not. This is 110 to 20 worldwide. This is only 110. This is residential, commercial, industrial. This is only residential. This has surge. This does not. This has GFCI. This does not. Okay, I can really go on. Okay,
It seems like it. Yes.
and here's the best part. This is our Gen 1. That's what we're going to go to market with right now with our partners. This is our Gen 2. This is
Wow.
gone
Wow.
totally. And that's what's going to be next. It's going
Wow.
to be a complete system on chip, a complete IC in here. And this is a computer right here.
And that means that you can put it anywhere because it fits anywhere.
Sure.
And that also means that as you scale and get into mass production, your costs go way, way, way down. You're using far less material and it can be printed, I guess, like a chip.
Absolutely. Look, something like this right now, it's somewhere around $80, $90. Okay. We can still be competitive at this stage.
Yes.
But when you get to this stage, by far, I mean, that's what makes silicon so attractive. It's not only smaller, but also it is cost effective.
Yeah.
And so, when you have something like an outlet, like in our outlets, for example, we have carbon monoxide, carbon dioxide, we have propane gas, even fire detection. We have Alexa enablement. We have motion for security. We have glass breakage sensor. We have all of these variety of sensors, capacitive touch, display, so many things in this case that allows, in this case, these outlets and switches to start learning humans' behavior, movements. That's what AI is all about. When it starts predicting, in this case, at 3 o'clock, John gets up every morning, gets at 3 o'clock in the morning to get a glass of water. Okay, now it predicts, it knows, and that ties it with security. And we have some IP, if you will, on the security side of it, where recognize, is it John or is it one of his kids or is it the wife now is walking around the house at 3 o'clock in the morning? There's so many things that we're adding on top of our hardware. We're not just really a hardware company. We're a complete system.
That's super interesting because you're placing intelligence everywhere throughout your house, and it's essentially the realization, in some sense, of the dream that intelligence is ambient, that it's not present just in a laptop or in a device in my hand or a physical device I see on my desk or something like that, but it's ambient throughout. It's also really neat. I mean, I at one point I had three sensors for just environmental sensors in the various floors of my home. And right now I've kind of gone down to one, but you know what? You could have CO2 in multiple places. You could have other particulate matter that's heavy in one room, perhaps, and not in another room. So if you had those sensors just kind of ambiently in the walls, wherever you happen to have a socket, that's a game changer. That's a real game changer.
John,
Very
I'm going to
cool.
throw a curveball at you. Why not put GFCI in every outlet in this case and save lives?
Yeah.
The only reason that you don't see them right now because they cost $25, $30 for a good GFCI. Okay, you find them for $10, but those are the ones that they're going to trip perhaps and nuisance and all the stuff. But a good GFCI is $25, $30, and those are, it's a life saving, and people don't put them in every outlet. For us, at the end of the day, it's embedded in our technology.
Yeah.
Yeah, we will charge for it, but I'm not going to charge $25 in this case if I don't have to, if I'm going to save people's life. It's not about money sometimes. You got to remember I came from life science, and when I see somebody can hear in this case and that smile on their face, okay, it's worth all of everything that I have done for the past 2 years and getting my butt kicked.
Wonderful. Well, this is very interesting. Let's talk a little bit about timing
Yes,
and cost. When will this be available? Is it commercially available? Is it going to be available to consumers or just distributors? What's that look like? What's the timing? And what are some of the costs that you're looking at right now?
perfect. So, John, I came to a conclusion that would be in the best interest of the company and the investors and the shareholders of the company is not to go out and keep raising money, if you will, and raise hundreds of millions of dollars to get into manufacturing and all the stuff, only to compete against the giants. Okay,
Yeah.
and it's not worth it. We're a technology company. We know what we do. We're good at what we do. So why not, in this case, come up with technologies? We have lots of technologies right now, and we have about 12 more in the pipeline that we can come up with, and enable these companies, okay, to take these technologies into their products and take them to market.
Yes.
So I would say we are now ready. We have over 25 companies that we're in discussions with. We have signed several agreements with some of these companies as a beginning towards contracts, if you will, and evaluating what is the first product, giving them the advantages to go to market, and whatever it is. So we're looking in this case to create partnerships between Amber and these manufacturers. It is not we do not supply them this. We're going to give them a complete solution and back them up and support them towards success. Their success will be our success at the end of the day. As far as costs, I have been asked, well, can you make this for $1.50? Can you make yours for $1.50? And I'm going to say, well, this is a computer, and this is maybe it's a lawnmower. Okay, so you're comparing an apple to an orange. Okay, so in this case, from cost, yes, we'll compete in this case on the cost against anyone out there that's smart or it's intelligent or something, but not just purely on and off. You
Yeah.
can't.
Yeah.
Okay, but even within the on and off, if it has certain features like dimming, for example, and the dimming is not as good as the dimming that we have, then
Hmm.
yes, I can compete for a dimmer, for a cost with our board before we even go to silicon.
Yeah.
So there are certain things that we are very cost effective, and there are some things where this is $8 total in the market, so maybe it costs them $1.50 to manufacture. This can be $1.50 to manufacture, at
Yes.
least not right now, maybe down the road.
Yes.
So we're very competitive. We feel very good. We're talking to these partners. They recognize that what we're bringing, it's cost. It is cost effective, so that we're keeping, in this case, their margins. They can still make the money, and at the same time keeping the cost of goods good and maintaining that same relationship that they have with the market. And our job is to make it more cost effective for them.
It's interesting that you mentioned the dimmer, because there's costs in there that you can't actually easily measure. So I do a chunk of the electrical work in my house myself. I don't claim any special expertise, but I'm okay with getting electrocuted occasionally. So I've replaced dimmer switches and stuff like that, and I'm pretty sure that for one case when we started getting LED lights and stuff like that, and trying to get a dimmer in that did not buzz, I probably went back 3 times for different dimmers, right? And so then, those are probably $80-$90 dimmers, I think, at the time that I was doing them. And it's the cost of the dimmer, sure, but it's also the frustration cost of me. Or if I was hiring somebody to do it and they had to go back 3 or 4 times, what's the cost of going back to the store, buying something, coming back? There's hours in there. There's hundreds of dollars of cost there. And what's the brand cost, actually? Because I buy this brand, and I'm not going to name. I forget which one it was, but there's multiple out there, and it says, hey, works well with LED dimmers, and it does not.
No.
And
Yeah.
it buzzes, and that's annoying, and now that brand has lost an opportunity to have business, but also future business.
Yeah, so I totally agree with you. See, if you take the sine wave, electrical sine wave, okay, we found a way to chop it, dice it, manipulate it, and including turning it to a straight line. So that means if we can do this, we can dim, in this case, from 0 to 100 without any flickering, okay? That's for the dimmers. I'm not talking about the lights, because we have a light solution also, but for the dimmers. So in this case, we came up with what we call it is a universal dimmer. And our
Yeah.
universal dimmer, in this case, will work with pretty much the majority of all of the LED lights, but we're not using a triac dimmers, which is an old technology, was invented in the 60s. And no, actually, on the contrary, we're using a solid state solution in this case for our dimming. And because of that, we can, in this case, give you a solution for dimming without any drop-offs, 25% or 75%, and then boom, it goes all the way bright, or drops totally to 0. We will give you a much better dimming solution. But keep something else in mind, John. Most homes were built prior to year 2000 based on only one wire coming in, one wire going out to these light switches.
Yeah.
They call it a 2-wire. There is no neutral. So therefore, they're limited, the manufacturers, to what kind of dimmers are they going to be putting in there. So that's why there's an issue. We don't care about neutral. We can still actually give you superior dimmers, in this case, for the 2-wire, with actually even intelligence, with some even dimming solutions into this wire, with very cost effective, perhaps even the same cost as right now what is being sold in the market. But in the meantime, we're going to give you much better dimming solution that you don't have to take it back, because manufacturers don't like people like you who's going to
No.
take it back. Yes.
I understand. Well, Thar, thank you so much for spending this time with us.
John,
Really do
thank
appreciate it.
you. It's a pleasure. Sincerely, thank you for giving me the opportunity.
It's a real pleasure. Everybody else, thank you for joining us on Tech First. My name is John Koetsier. I appreciate you being along for the ride. Hey, whatever platform you're watching on, like, subscribe, share, comment, all the above. If you're on the podcast later on, rate it, review it. That'd be a massive help. Thank you. Until next time, this is John Koetsier with Tech First.